Go Language Programming, Chapter 6, Unit 1. In this unit, we will cover packages, creating custom packages, nested package scope, package name conflicts, dot imports, and package documentation. So far, we have seen Go language programs that have only one file with an entry point routine or the main function, and few other functions or methods. In a real world scenario, this approach of writing all source code in a single file is not scalable. It becomes impossible to reuse and maintain a code written in a single source file. This is where packages are helpful. So a package is nothing but a directory with some source code files which exposes different variables or the features from a single point of reference. So packages are used for organizing Go language source code for better reusability and readability. Just like the way directory structure is used for organizing files on your hard drive, packages basically achieve the same kind of a concept. Since packages live in their own directory, therefore packages provide code like a compartmentalization, and hence it becomes easy to maintain Go language projects because each package directory might have several Go language files specific to that particular package, and that will make your code easy to maintain. So let's go and understand more in detail. So an important part of, as we discussed just now, the high quality software is to be able to reuse. Okay, so the code reuse is very important thing in writing some or coming up with some product. Even in other languages besides Go, code reuse it has become a very important part, especially like a language like C++. So Go was designed to be a language that encourages good software engineering practicing. So that is the whole idea behind the concept of writing the Go or the programs in Go language. It is basically designed so code becomes easy to maintain and easy to enhance and easy to add new features. All of those things you can do it if you have created the packages properly. Functions in all programming languages are the first layer to allow the code reuse. So, that is what when we write a piece of code, in every any language, that you use functions, because functions are the one which they provide a way to write a very small piece, and that same piece you can use it many times within your same source code file, or even in a different source code file. So that means that is the concept of reusing the functions. So you don't have to be rewriting the same piece of code. All you do is to make a some function call, and that's it. So you are reusing the functions that you have, function body that you have written only one time. So Go language provides a standard library packages, and we've been using that package FMT, okay, for IO related code. And that, as you can see, it has been reused many times. So the way that FMT package is written is basically, we import that package in our source code, and we don't even need to know any details about FMT package, how it has been written. All we need to know is the APIs that this FMT package provides, so we can make a call of those APIs in our source code, and basically do the IO. You can use this command go list std, okay, at your operating system prompt, and it will basically list all the standard packages that are available in Go language. So that is a one way to find out how many different standard packages are available, and there are many standard packages. So basically, nobody would really remember all those standard packages name unless you actually started them using in your own code, that when you write it, so when you import some standard package and you are basically very frequently using that package, then you would be able to remember all the functionality that is provided in that specific standard package. So the packages organize the code so that it is easier to find code that can be reused. So basically, when you write a package, that will be the most important part, that you write it in a way that the package is organized in such a way that the code can be reused from your package, because there there's a right way to write the package, and then there is a wrong way to write the package, and we will go through some of the examples in this unit. So packages speed up the compiler by only requiring recompilation of a small chunk of program. So you see, if you have the package, and like for example, when you use or import FMT package, that FMT package gets compiled only one time, and then after that, you can do as many compilation as you like in your code, or for your code. FMT package is not going to recompile again and again. Okay, it's just compiled only one time. So as you can see, it really speeds up the compilation process. Okay, as since since when anybody is developing any code, usually developers compile their code many times, hundreds of times, to do some unit testing, or to check out the logic is working properly or not. So basically, that means, FMT package, if you have imported that, it will be just compiled only one time. So when FMT package is used in source code file, it does not uh, recompile every time. Okay, and that's what we just covered. It just recompiles very first time, and that's about it. So the first line of every source listing of Go application must contain package and the package name. Okay, so that's the syntax for writing the source code for Go language. Okay, so compiler always will look for the very first line that has a package name in there, and then it will allow you to compile. Otherwise, it will generate an error. So two types of packages are there. One is executable package, and the other one is utility packages. Okay. So the executable package is the one that has the entry point routine, and that's what we've been using it. So when we write our source code so far, we have a package main, and then within that package main, you have entry point routine on that source file. This is the entry point routine func main. Okay, so you can even have multiple source code files for the executables, but you just will have only one func main, for the whole project. So if, let's say you have 10 different source files, and every source file must start with a package main first line in every source file, but every source file would not have this entry point routine. Only one of the file will have the entry point routine. So executable package is a main application, since it will be running. So that's the basically main application. Okay, utility package, such as that we have been using FMT for IO purpose, is not self-executable. Okay, so it cannot execute by itself. So basically, any package that you write, it would not be it cannot execute. It does not have an entry point routine. So it enhances the functionality of an executable package by exporting its functions. So that's the whole idea. So there are lots of functions which are exported from, for example, from the FMT package. Okay, and such as scanf and printf, and both of them has many different versions of those functions, and we're going to discuss if you when you write your own custom package, how you can export the functions or the variables or even structs. So let's see in the next slide. Okay, so creating the custom packages. So it is recommended to use plain and simple package names. So please remember, whenever you're writing a package, you don't need to be very creative to come up with some words which are very difficult. You just have the package name as simple as possible, as short as possible. So when you import that package, then your source code, wherever you import it, your source code file would not would not have a very lengthy package names. Okay, so a package name with underscore, so underscore, hyphen, or mixed caps should be avoided. Okay, so that's the recommendation from all the Go language developers. You should not try to use any of these underscores, hyphens, or mixed caps. Okay, you should always have all small characters for the package name. Remember, package is nothing but a directory name. Okay, so basically that means since your package code will be sitting in a directory, you might have for the package, you might have multiple files, multiple Go files. So that means you have to be making sure that the directory name that you give is pretty simple, and all small characters. That is the preferred way to give a name for the package. Okay, because package name actually will become the directory for all this code. So Go package exports a variable if variable name starts with the uppercase. So that's the key part. Okay, so when you write a package and you have some variables in the package that you want your application to be able to use those variables, then you need to give them uppercase, first character uppercase. Okay, that means in other languages like C++ have created a special keyword for it, like a public. Okay, but in Go language, like the developers of the Go language, they wanted to keep the language as simple as possible. Okay, and that's why, like we talked in the previous lecture, that is the one reason that Go has only 25 keywords, and that's it. Okay, it does not have more than 25 keywords. So, like C++ has a keyword like private and public and protected and class, and so forth. So Go doesn't have any of those kind of keywords. They wanted to keep the language as simple as possible, so the developers can concentrate on writing the code with the vocabulary that is provided. Vocabulary meaning that the keywords that is provided by the Go syntax. Okay, so whenever you need to export a variable or a struct field, you need to make sure that the first character of those names are uppercases. So package variable not starting with the uppercase letter are private. So that means they are not exported. Okay, in Go language they call unexported. Okay, they don't call it private actually. I'm just using it here so for the purpose of explaining, but in general the unexported means private. That means wherever the package will be imported in whichever executable, that executable would not have access to any lowercase variables or lowercase data structures. Okay, source files belonging to a package should be placed in a package folder. Okay, so that's what we just talked about earlier, that anytime that you are coming up with your own package, that means you will have some source files. So for that reason, you create the name of the directory as the same name as the package name, and within that directory, you will put in all the on the your source files. So that uh, each source files in that directory must have a first line starting with the package name. So it will say a keyword package and then after that, package name. Okay, so that's how every file within that package directory will be starting, and then rest is the logic for your code. Um, so it is a convention in Go language to name folder with the same name as the package name, and that's what we just went over. Okay, always remember that you need to name the package name same as the directory name or the folder name. All files inside the package folder should start with a line package. So that's what we just discussed as well. So package first line in a source file will have a package and then the name of the package. Okay, no matter how many files that you have in the package folder. So specify the relative path to custom package when when importing it in an application. So basically, relative path means that whenever wherever your package is located, when you import, like in this case, in this example, when I'm importing this rectangle, I'm giving this relative path. Okay, so that means in the current directory, this package is located. Okay, so that's how you give the complete path wherever the package is located. Okay, and that's how you import your package. So let's look at this example 6-1A. Okay, in the 6-1A, the first code that we are going is is an executable file. Okay, and then we will go over actual package code itself. So as since this is an executable file, um, this must start with a package main. Okay, because this file will have an entry point routine func main. Okay, like you see it at line number 8. So as soon as you start, then you have to tell the compiler that okay, you want to import these packages. So this fmt package, which we've been using it all along, which is coming from the standard library, and then at line number 4 and 5, these are the custom packages. Okay, rectangle and geometry, these are both custom packages. Now the path, as I just said, that in this case, the path is relative to the current directory. Okay, and that's where these geometry and rectangle directories are located. So so your executable knows where the packages are located during the compile time. Okay, so within the main function or the entry point routine, at line number 9, what we are doing is creating the variables, rack length, rack width, rectangle length, rectangle width, and then giving them it a type. Okay, and assigning it with the values. So so in this case, rack length will be 6 and rack width will be 7. Okay, so you can assign, as we have talked in the previous lectures, that you can assign multiple values to the variables on the left side of an equal sign, if you have multiple variables as well. And then, of course, at line number 10 is just FMT package is used for using the print line function, so we can display this geometrical shape string. And then at line number 13, we have again this area of rectangle. Okay, so in this case, what we have is that this printf is continuing in the line number 14 as well. So within the parentheses for printf, make using this rectangle dot area. So rectangle is this package name, and dot area is the function that we will see it in a minute. Is a part of the package, and this area function is taking two parameters, rect length and rect width. Okay, and then at line number uh, 17, again we want to call the diagonal function from the rectangle package. So we are calling the diagonal function with, of course, with the dot operator, because it's inside the package. And notice that with FMT that the functions start with function name start with a capital letter. Similarly, your custom package will have a capital letter because they are the one these functions are the one which are exported. Okay, and once you run this code, this will be the output. Now let's go into a little bit detail about what is legal and what is not legal. Okay, so it is illegal in Go language to import a package and not to use it. Okay, so you cannot have a package and you say, okay, I don't want to use it. Like, for example, okay, I'm doing right here geometry. As you can see, within this piece of code, I do not use this geometry. Okay, so if I just have it in my code, then basically a compiler will generate an error. Okay, so for that reason, you what you need to do is you need to put in this underscore right before the package name. Okay, so when you put it, so underscore is a blank identifier. Okay, that's what the underscore is, and I believe we have talked about the underscores in a different context in the previous lectures as well. So this is basically a blank identifier to silence the compiler error. Okay, so compiler doesn't complain if you are not using the package itself, and you have the package name imported in your code. Okay, if you don't have the underscore in front of the package name, then compiler will complain. So basically, only if geometry package folder should have at least one package source line. So now that is also important to remember. Your if you are silencing and you said, okay, I'm just going to not even have a directory, geometry directory package, and I just want to have it for the reminding me, so I will put a code later and import this package later. But and even if you put the silencer or the underscore in front of it, compiler will still generate an error. Okay, and so that means basically you need to have a directory created, okay, for the geometry, and within that directory you need to create at least one source file that will have one line in it, the very first line, which every source file will have the package name, package and then the package name. So basically that source file should have a package and then space and then geometry. Okay, so then compiler will be happy, and then you can put underscore in there. Okay, so it will work then. So basically, to silence the compiler, you have to put underscore in front of the package name, so compiler doesn't complain. But the package must have its directory created and within that directory there must be at least one file, okay, with the very first line saying package name itself. You keep track of silencers and make sure to remove them, so basically, during the development, you put in quite a bit code for the purpose of thinking that, okay, while you're writing your code, some logic comes in your head, and then you say, okay, I'm it will take a little extra time so to make your code work, and you need to have the logic also. So what do, you either write the logic and comment it out, or write some logic un, uh, um, unfinished logic and leave it in your code, but then, I have seen a lot of code that the logic is there even after the whole product is done, and even the product is getting shipped to customer, and that incomplete logic is there, okay, because the person who was writing it, they made it they commented it out, okay. So those are the important things that you need to remember. So in this case, if if you know that, okay, now for example, geometry package is not really needed in your code, then you need to remove this line, so it doesn't clutter the code. Okay. So the function, so now what we're going to do is in example 6-1b and 6-1c, we'll go over the package code. Okay. So the function names area and diagonal starts with the uppercase, as we, in the previous slide that we talked about it. Okay, because they are the one that they're going to be exported. Okay, when we say exported, that means these are the functions they need to be able to um, uh, uh, be able to use in your executable code. Okay, so that's why they need to be exported, and of course, the exported means they have a first character uppercase. So only exported functions and variables can be accessed from other packages. So you can access those exported variables or the function names or the data structures from other packages. Now, it doesn't only have to be imported on those packages, doesn't only have to be imported in your executable files. This package can be imported from one package to another package. So you wrote some other package, and the code need to be imported as well. So then all you have to make sure is they are uppercase so they can be imported. Okay. So now let's look at this following code. Example 1b, under, so this is under the rectangle directory, okay, or the rectangle folder. So in this code, very first line, as you can see, so package, when you create your own package, this is the very first line that you have to have, and the package name, whatever the name that you decide. Okay, so in this case, we have a rectangle, and then we import a regular library package called math. Okay, so the math package is imported, and then we have a function in this package code called area, and then the other function called diagonal. Okay, and they are just regular functions. They are taking the parameters, and then it has a return value, and then within the body of the function, it basically multiplies the parameters and returns the some value. So this area is going to be of type float 64. Okay, so now let's look at the diagonal. Diagonal is also taking two different parameters, pass by value. So they both are passing by value. It's also returning the float 64. And then diagonal is the one which is actually using this math package. Okay, so math dot square root. Okay, so square root, as you can see, the very first character of the function, which is in the math package, is a uppercase. So that means this function is exported from the math package, and then this function takes, this I guess this takes one parameter. It has multiplies it, and then so square root it function takes only one parameter, and then it has a return. Okay, so that's how the packages are written. Now, your following code in like we talked about earlier, that the geometry, that package that you still are, or it is still under development. The code is not finished. Okay, for example, but you have it in your executable file, and we put underscore in front of it in the previous slide that you just saw. Okay, so now this file that that is in under this directory. Okay, it must at least will have one line, this line package geometry, and that's it. If you don't have any file, okay, or if you put a file in there and not with this line, then you will get an error as well. Okay, so if geometry package folder is empty and geometry package is imported in main application, compiler will generate an error, and that's what I've been talking about. Okay, so your whole code for your packages are the directory structure is this one. Okay, so we have this project, you can give any name, but these are the names that are important, rectangle and geometry, because these two are the names which are imported in your main executable, which is this one. Okay, so this is how the export of the variables or functions are done in Go language. Now let's look at the nested package. Okay, what does it mean, and how the Go supports the nested packages. So nest a package inside another package. So that's what it means. Okay, so package inside the package is just like nesting the for loop, for example, one for loop inside another for loop. Okay, or nesting the structs, which we have already talked about many times. So this is a similar concept. You're nesting the packages here. So package is just a directory, as we just finished talking about it. It's just nothing but a directory which holds all the related files to that particular package. So it's like creating a subdirectory. So you basically create another directory inside already existing package directory. Okay, so that's how you nest the packages. So so one directory created, and then the child directory will be created. Okay, for the child package. Provide a relative path of the nested package. So you need to make sure that you gave a proper path, in your one upper layer package when you are importing it, because you have to import, right? That is the reason that you have a sub package. So to run a command that compiles Go language source and execute a program. So Go run, that basically we have talked about in the previous lectures. The Go run will run your code, and it will compile and run it and display it. So that's how you can compile your Go language source code. The go install, okay, command compiles the packages and creates a library, executable files, or package archive. Okay, so basically, you will see that when you do this go install, you will see that package archive will be created with the .a extension. Okay, after installing third-party packages, Go language compiles the Go package and creates the package archive. Okay, so when you basically get the third-party package, that package also has to be compiled. So remember, as we talked earlier, the package code will be only compiled one time, and then it will be reused again and again, no matter how many times that you do the compilation of your own code. Okay. So you use go get, okay, command to download the package name by import path along with their dependencies, and then install the packages. So this go get will allow you to get the package, okay, whatever the package that you want to get, and install it on your local machine. And then when you're using in the import, so in path that does the correspond to the repository. So basically, in the imports, wherever you are importing the package, you have to give a complete complete path. Okay, so it can compile your executables. Um, so that's how the nested packages that we just talked about is to create subdirectory within the package directory. Okay, so the subdirectory will be another package itself. Okay, let's look at package scope. What is the scope of the package? So package scope is a region within a package where a declared variable is accessible from within a package across all the files in the package folder. Okay, so basically, that means, of course, if you have a variable, declare a global variable, okay, in one file, and then that global variable within the package folder, you have like 10 files, and all 10 of those files are using that global variable. So then, but that global variable only will have to be seen only by that package. So then that means you will not be exporting that variable. Okay, because if you are exporting, that means your executable will be able to see it too, but you just want the package files, no matter how many package files are in the package directory, they should be able to see that global variable. Okay, so that variable has a basically across all the files in the package folder. Okay, so it can see that particular variable, global variable. So this region is the topmost block of any files in the package. So it is like a, the scope is at the topmost level, topmost block, that variable will have. So it is basically available to all the files within the package directory. Okay, package name conflict. Now, there is quite possible that you have downloaded packages, okay, and your third party package or your friend give it to you a package, but the package names are same. Okay, so what do you do? When you so if you have downloaded it, remember, those packages, when you download it, they will be under their own directories. Maybe they will have under the subdirectories or whatever, but they will be under, there is some uh, structure for where the packages will be located. So basically, what you can do is to you can when you import, during the import of the package, you can literally customize the package name. Okay, so then when you are using any functions from the package, or the variables from that package, they cannot be they would not have any conflicts. So customize the package name under which you prefer or you refer to an imported package. Okay, so how do you customize? You basically, so these are the two standard library packages, crypto and math. Okay, they both have this random package under. So these are, random is a subdirectories under the crypto. Okay, and another random is a subdirectory under the math. Okay, now in this case, if you want to use some functionality, it will be very difficult. So that for that reason, you can customize these names. Okay, so you can just say C random and M random. So basically, that means crypto random from the under the crypto package, and random from under the math package. Okay, so custom name on the left side. So this is the left side, okay, of the package name. So this is the package name right here. This is your package name, and on the left side, while importing the package. Okay, so that's how you can customize the package. So even if you so people also do it. It doesn't have to be that the package names are conflicting. Sometimes some people do this this uh, customizing the name of the package, is because either they don't like the name of the package, or the package name is very long, so then they will make it short so they can use it within their code. Okay, remember, to call the function, so from that package, you need to have the package name and then the dot operator. Okay, so not necessarily that you always have to only customize if the package names are same. Even if they are not same, you still can customize it, and there would not be any issues. So after customizing it in the main routine, I'm using this m random. So m random is this one from the math package, or under the math package. Okay, so this int is the function that is called. So this function under the random package, which is under the math, it does a sequencing of numbers, for the randomness, that satisfies the randomness. And then at line number 10, we are creating a slice. Okay, we're creating a slice which will have the length and capacity 8. Okay, both length and the capacity will be 8. And then we are uh, you know using the read function from the crypto package. Okay, I shouldn't say from the crypto package. We are reading it from the random package, which is under the crypto package, for the purpose of cryptographically securing the pseudo randoms. Okay, so that's what this will allow us to do. And in this case, when we do the print line on this n and b variables, then what happens here? is that this number right here that you see, okay, is coming from the sequence of numbers. So this number will be always be same in your code, but this these numbers will always change. Okay, so these are the pseudo random numbers. So that's how this code works. So and then in this code we went over how to resolve the conflicts between the packages. Okay. Okay. Dot imports. So let's see what the dot imports means. So if a period appears next to the package name, okay, period appears next to the package name in an import statement, all the packages exported identifiers can be accessed without a package qualifier, meaning package without the package name. Okay, so you would not even need to have the package name. You can just, as long as you, of course, you know the APIs that are provided in the package. You need to know that, like printf, for example, capital P and print f in the FMT package. You can just not to do the fmt dot printf. You can just say printf and then it should work. Okay, so if package name is used to call the function from the package and dot appears next to the package name, Go compiler will generate an error. Okay, so now in this case, basically, what we are saying is if a package name is used to call the function from the package and dot appears next to a package name, Go language compiler. So basically, if you have this and then you still use the package name to call the function, then the compiler will generate an error. Okay, so if you use the dot operator, you should not use the package name when you're making a call of the function. So in this example, we are importing this FMT, of course, and then math package. So math package, what we want to be able to do is to not use the math package name before calling the its functions. Okay, so we do not need to say that math dot sign, sign function. So basically, then we put a dot in there and you can do that. So here in the main entry routine, in this print line function, as you can see, I'm just using a sign function from the math package. I'm using a pi, okay, which is already constant declared in the math function. Again, the sign function is also within the math package. Cosine is also in the math package, and the pi is a constant which is in the math package. So as you can see, I do not need to have the math dot sign or math dot pi. I would not need to do any of that stuff. Okay, if I put this dot in front of the when I'm importing it. Okay, so then basically and that way code might look a little simpler. You think it looks simpler, but this is a very simple code. But I would say it could become very confusing if you keep doing it in your code without the package name. If you're calling the functions from the package without the its name, so then the code will become very, very difficult to read. Okay. So I would really always use a package name to call its functions, to make the basically code readable, and that means your code will be maintainable, and easy to fix the bugs and so forth. Okay, so let's look at the how you can access the documentation, Go language documentation. Okay, or the package, even the package documentation. So basic idea is that what you do is you need to start a server. Okay, now we will cover our own writing our own servers, I think in chapter 8 or 9. Okay, so but this one, that the one that we are talking about right now, is already provided to us with the Go compiler. Okay, so using the following command on Linux system, I don't have a really Windows, so I don't know how it works under Windows, but under the Linux system, you start a web server. Okay, just like this. You say go doc, and then dash http equals to colon 6060 is a port number that you are starting this web server, and this I mean the ampersand sign means you are starting this web server in the background. So basically your web server will be running in the background. Okay, now to access what's the pages from, or make a request to this web server which is running on your local system. It's not going to go on any websites or anything like that. It is just going to be running on your local system. Okay, so to access the web server on your local system, all you do is to type in this http localhost, and then give it a same port number 6060. Now whatever the port number, you can change this 6060 to whatever the available port are available on your system. Okay, but this port number and this port number must match for the web pages to be served by the web by this GoDoc web server. Okay, so that's how you start the web server locally on your system. Okay, and once you put in this in your URL in your browser, then what you will see, the page will come up. This is the page. Okay, this is the page that will come up on your in your browser. So basically by typing it in, this localhost colon 6060, it will give you this page. And in here, as you can see, there are a lot of different topics. You can just go and visit them, and learn, because it's a complete documentation for the Go language. And it will it will go into quite a bit detail about several different things. So I would recommend that you should really learn how to use this. First of all, your this uh, how to start this web server on your local machine, and communicate with your browser. Okay, so this is basically it for unit 1, chapter 6. This concludes this chapter. uh, so we will start chapter number I mean unit 2.